Welcome again. Today, we're going to discuss about um, some graph of a cell physiology, and it will be a factor on number one. We'll just discuss one factor at a time, but our factor here that we need to discuss today is which factor? It's a factor of active transport, and it's based on oxygen concentration. So you understand about the oxygen concentration. So the question reads, we have the relationship between oxygen concentration, sugar consumption, and potassium ions uptake in isolated weed roots was determined. The results obtained were tabulated as shown below. The laws of sugar and potassium uptake are in arbitrary units. Percentage oxygen stream, you have the sugar loss, and you have potassium gain. But percentage, you can see 0%, 5%, 10%, 15, 20, 30, and 40 respectively. But the sugar loss, when it was 0, sugar loss was 15. Potassium ion gain was 5. As we increased the oxygen, sugar loss also increased to 20. As we continue increasing, it increased to 45 at 15 oxygen percent. But as we continue increasing, there was start of decreasing the sugar loss. In terms of the potassium uptake, it increased up to a certain point where it started to decrease. You can see by 15, it had increased to 275. When the sugar loss started to decrease, also the potassium ion decreased. So let's check. You plot a graph of sugar loss and potassium ion gain against oxygen concentration on the same axis. And you can check from this point, you check your x-axis. We are speaking about this point. This is your x-axis. And you can check on your x-axis. The x-axis, you can check we have oxygen concentration. And the values you are seeing here, can you check the origin? The origin is the most important part when it comes to a graph. This 0 should not touch at any of these lines. When it touches any of this line, it means one of the axes will be missing an origin. So this is the origin, and it's a shared origin. When you divide this way, halfway, you will get 2 divided equal 0. So we have 10, 20, 30, 40, 50, and 60. It means it's consistent. It is consistent. And you can check the highest value here. We have how much? We have a 30. So we are speaking, it's about oxygen concentration. And when you check percentage of oxygen, it's at to 30. So there was extension from 30 to what? 60. Then on this other section, we have the same 0, 10, 20, 30, 40, 50, 60 to 80. And our last value here is 75. So your graph should not end at your end value. It should extend. So we have the sugar loss and the potassium ions. Sugar loss and potassium ion gain. And we are saying those should be in arbitrary units. So here you should add in arbitrary units. Then we have this one, it's oxygen concentration in percent. So this one is incomplete. We are saying oxygen concentration in what? Percent. So our first question, identify the process. Identify the process through which potassium ions are taken by the roots. And this one is, we are saying this is a factor of active transport. And there should be energy requirement. So it should be active transport. That is number one. Active what? Transport. That is our answer. Give a reason why it's active transport and not any other process. The main reason is oxygen is required for respiration. We are dealing with factor of oxygen. So what is the role of oxygen? It's required for oxidation. So oxygen is required for respiration to produce energy. Hence, that's the first one. Hence, uptake of potassium ions is, we're speaking about uptake of oxygen ions is low when oxygen concentration is low. Uptake of potassium ions is low when oxygen concentration is low and increase with increase in oxygen concentration. What are we? Let's explain this briefly. We're saying oxygen is required for oxidation. So the more the oxygen, the more the oxidation. And the more the oxidation, the more the respiration rate. The more the respiration, the more the yield of energy. And the more the yield of energy, the more the active of those ions. So there is a relationship between potassium uptake and the oxygen. The more the oxygen, the more the uptake of these ions. The less the oxygen, the less this one. Because we have said oxygen is for oxidation, and the more the oxidation, the more the respiration, and the more the yield of energy. Thus it means high uptake of those mineral salts, that's the potassium. Number 2, account for the sugar loss and potassium gain at 0% concentration. At 0% concentration. You can check even from your values. It was 0 sugar loss, we are losing 15, then potassium gain is at 5, it's still low. And you can check from this point, the initial of your graph, it's at the start, it's still very low as compared to this other rise. And the main reason, what's the main reason for that? At this 0%, there is no respiration at all. 0 oxygen concentration, we are saying low oxidation. So there is no even oxidation. So there's no respiration process taking place, making process taking place, hence potassium ion intake is very low because there is no energy for the process. So it means those ions will just be taken up by diffusion. Those less ions which have been taken are being taken by diffusion rather than active transfer, because we don't have oxygen, we don't have respiration. No respiration, no yield of energy. No yield of energy, it means those ions will be taken by which process? By diffusion. Then we have this is because we're saying the sugars have not been broken down to release energy. Because we're speaking about sugar loss. Even the sugar breakdown is still low because there is no oxygen to break that substrate, which is the glucose, and there will be no release of energy because no release of energy, there is no that. Then number 2, what's the you account between 5 and 20 decrease percent oxygen concentration. When you check about, we're speaking 5 to 20, this oxygen, you can check from this 5 to 20, 5 is something of this kind to 20. You can check there was an increase in sugar loss and also an increase in potassium uptake. What's the main reason? We're speaking about 5 to 20. Potassium ion uptake first increases at a slow rate. That is at around that 5%. It's increasing at a slow rate and then rapidly to its maximum due to the optimum energy. That is not the full explanation. We speak about sugar loss also increases because it's used as a substrate during the respiration process due to high oxygen concentration. Hope you understand this one. We are saying as we increase the oxygen concentration, there will be increased respiration because of increased oxidation. So the increased oxidation, increased the respiration, increase the respiration, increase the yield of energy. And again, we're speaking about the sugar loss. Sugar loss is the one that is used as the substrate in the respiration process. So there will be increase in the breakdown of the sugars. And because of the increase in the breakdown of the sugars, what happens? There will be increased yield of energy and there will be more uptake of potassium ions, which will increase faster at a slow rate because of the low concentration of oxygen. Then as the oxygen increases, there will be increase in buildup of energy and there will be increased active uptake. That is increased active transport for the uptake of those mineral salts. Then state factors necessary for the process and apart from oxygen concentration. We have more. Optimum temperature, optimum pH, optimum pH. We have substrate concentration. We are speaking about what? Apart from oxygen, but it's not positive or negative. Even we have now the enzyme inhibitors. So we are speaking about this one. Optimum pH for the respiratory enzymes, availability of glucose, that is the substrate, optimum temperature, then presence of the coenzymes and cofactors that will not be present at this point. It will not be too much necessary. Then state the role of diffusion in animals. Role of diffusion in animals. We are dealing with the factor of active transport, but now these are very different questions away from what we are discussing. These are role of what diffusion in animals, and the first one is excretion, stroke removal of the nitrogenous waste in some animals. That's number one. Number two, gaseous across respiratory service. So we are not speaking about in, but across. We're speaking what? Across respiratory service. We have about absorption of digested food. Absorption of what? Digested food in the ileum into the bloodstream. Absorption of digested food in the ileum into the bloodstream. Then we have again reabsorption of useful substances and some salts in the kidney. You can check well. So we're speaking about what? Removal of nitrogenous waste, gaseous exchange across the respiratory service, absorption of digested food in the ileum into the bloodstream, reabsorption of useful substances and some salts in the kidney. That is it, and that is the end of our 20 mark graphical on active transport based on oxygen. So you can subscribe as we learn more. Thank you very much.